today we are going to finish functions of the endocrine system. So we're going to go through the rest of the glands, the organs. Not nearly as many hormones today because the pituitary is the one that really has half the hormones that we learn about. So yesterday we did the pituitary gland with all the different hormones it did. We did the thyroid gland, which mostly was thyroxine that controlled the metabolism. And then we did the parathormone, which was mostly for raising up blood calcium levels with thymosin. So parathormone. So today we are going to do the thymus gland. Again, please don't confuse because it's so easy to do. The thyroid, the butterfly that wraps around your neck, with the thymus, the one that's over the heart, because you must have a heart. So thymus makes thymosin. They really just phoned in these names like parathyroid and parathormone, thymus, thymosin. Come on, guys. Actually, I think I appreciate it because it makes it easy to remember. So thymosin is the hormone that the thymus releases. Remember that the thymus was also in the lymphatic system because it deals with white blood cells and your immunity, and so does thymosin. So thymosin stimulates this specific type of white blood cell, and I'm perfectly fine with you thinking it just stimulates white blood cells, a specific type of white blood cell, to mature. If you're curious, the lymphocytes were the one that made the antibodies, little bullets that go out and shoot people. Sorry, not people, viruses and bacteria. And this T stands for thymus because they can grow up in a couple different places. And if they grow up in the thymus, then we call them T lymphocytes. But again, thymosin matures white blood cells. That's perfectly fine. There you go. That's a white blood cell. Now, remember I said that it was really important to remember that the adrenal glands, the little triangles that sit on top of the kidneys, have a cortex and a medulla, and this is why. Because the cortex makes a type of hormone called corticoids, or we call them corticosteroids. So anytime you get a steroid from a doctor, it's this. It's a corticosteroid. It's one of the hormones that the cortex of the adrenal gland usually makes. Also, it makes something called androgens. Androgens are super similar to like testosterone. These are male sex hormones. Everyone has them, but males have way, way more of them. Now, if you were the medulla, the middle, the inside, the peachier color here, then you make adrenaline, basically. So epinephrine is a fancy name for adrenaline. So we're going to talk about these in more detail on this slide. So cortex, the outside part, makes corticosteroids. They will almost always be called corticosteroids. And I really prefer you learn corticosteroids because then that reminds you, yes, they're from the cortex, but they're steroids. And we've talked so much about how steroids are anti-inflammatory. They calm down your immune system. I would like you to also know that they increase your blood sugar just because people who have to go on steroids, a lot of times they have blood sugar issues. But what I want you to really learn about the corticosteroids, which is a whole big family of hormones, there's a lot of different types, but all of them are anti-inflammatory. So when you're having inflammation, when your body's attacking itself and swelling all up, it will go in and calm down your body. Adrenal cortex also makes androgens, which are male sex hormones. It is not testosterone. Testosterone is made in the testes, but it is very similar to testosterone. We also call these anabolic steroids. So these corticosteroids are the doctor type of steroids, the ones that they prescribe you when you have a rash or when your tonsils are really swollen. These are weightlifter back alley steroids. These are the steroids that people abuse in order to gain muscle mass and get all buff and stuff, but it ain't worth it, and we'll talk about why when we talk about disorders. So the medulla, those two that we just talked about were cortex of the adrenal gland. Now this is medulla of the adrenal gland, makes epinephrine. For the purposes of this class, you can just think norepinephrine and epinephrine are the same thing. They are very, very close to the same hormone. This one's just a tiny bit different. The general public calls epinephrine adrenaline. So remember that adrenaline and epinephrine is the hormone that stimulates your sympathetic nervous system and makes those fight or flight reactions. So it's what makes your pupils dilate and you to breathe faster and your heart rate to increase and more blood to go to your skeletal muscles, but less blood to go to your digestive tract. it causes all of those fight or flight reactions. And that's from the medulla of the adrenal gland. Next comes gonad. So we'll start with the female gonad, which is the ovary. These two hormones, again, are huge for the reproductive system. So go ahead and learn them now. Estrogen is responsible for female, everything that is female-y. So breast development, the endometrium is the inner lining of the uterus. This is what sheds monthly in a female. This is what comes out during a period. The endometrium, endo inside of, and then metri always deals with the uterus. So it makes your female organs develop. Initially, it is responsible for breast development during puberty, and it's responsible for this endometrium thickening every month that will shed if you do not get pregnant during menstruation, which is your female's period. The endometrium is also thickened by the progesterone. So estrogen does like a lot, everything female-y. Progesterone's whole job in life is to build up that thick endometrium so that a baby has a place to crash land in case it gets made. If it does not get a baby, it rage quits and comes out every month. So the follicle stimulating hormone and luteinizing hormone were really, really important in reproduction cycle of a female. And then estrogen and progesterone are the last two that are really important. The male gonad, the testes, makes testosterone, which everything that estrogen does in a female, testosterone does in a male. So it's responsible for male type of traits. So growth of beard and body hair, onset during puberty and then stays throughout life. Deepening of voice, it's what makes the larynx, the voice box, stretch in a man to stretch on those vocal cords and lower his voice during puberty. Increase in muscle mass. When you go through puberty, males get more muscular. They kind of lose that little boy body and they get muscles. And then production of sperm, also done by testosterone. Follicle stimulating hormone helped as well, though. All right, and so our last organ for today and the last two hormones that we'll talk about are insulin and glucagon. Again, just like when we talked about the thyroid, I said, please focus mostly on thyroxine. And we just kind of said, all right, calcitonin is another thing it does. For the pancreas, focus mostly on insulin. We will mention glucagon, but this is the one it's famous for. So the pancreas, remember, was both endocrine because it makes insulin and glucagon, but it was also exocrine in the digestive system. So these green tubes are releasing the pancreas's digestive enzymes into the small intestines. These little blue dots are the islets of Langerhans, and that's what makes its endocrine hormones, the insulin and the glucagon. So insulin helps you to use glucose. It's the main thing. It helps. How do I explain this? So you eat food, right? And your body breaks that down into sugar. That sugar needs to be used by your muscles and your organs and everything as fuel for energy. It's basically your gas, right? Like a car. So it can only use it if insulin opens the door and lets it into the muscle. So you will have blood sugar floating around that is useless to you if you don't have insulin to open the door and let it in. Very similar to how your body can't use calcium unless you get enough vitamin D. Your body can't use sugar unless you get insulin. It does some other things, but don't worry about it. So when you have high blood sugar, hyper, high, gly means glucose, which is sugar, and emia is in the blood. When you have really high blood sugar, your body says, oh, we should probably be using some of the sugar in the cells. And so it releases insulin that lets that sugar out of the blood, which solves the hyperglycemia, and into like your muscles and things like that so that it can use it for energy. So if people with diabetes don't have enough insulin, so when they don't have enough insulin, what happens is their blood sugar gets high. Now, a lot of people are confused when I say that because they're used to like diabetics saying I have low blood sugar. Diabetics only have low blood sugar if they take too much medicine, if they inject themselves with too much insulin and then didn't eat enough. If diabetics don't treat their diabetes whatsoever, they end up with incredibly high blood sugar. And that's what causes all the problems with the blood vessels is the sugar, so much sugar in their blood scraping the inside of those blood vessel walls. Now that's insulin. Glucagon is the exact opposite. So it's also made in the islets of Langerhans, but glucagon you need when all your glucose is gone. Aren't I clever? So this is released when blood sugar is gone, when there is no blood sugar, when you have hypoglycemia. And what it does is goes in, remember the liver, I said stores glucose as glycogen? It's the hammer that goes in and breaks down those glycogen walls so that we can release that sugar into the bloodstream when you need more of it. So again, glucagon when all your glucose is gone, but what I really want you to focus on is insulin when you have high blood sugar. Insulin is what lets that sugar out of the blood because it was too high there and into the cell where it needs to be used for energy. Okay, I believe, yep, that's it, guys. That's all for today. So tomorrow we'll start talking about, or the next school day, whatever, we'll start talking about disorders, which again is just going to be like, well, what happens when your body makes too much of it and what happens when your body makes too little of it. So really, 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 you got to know these functions of these hormones backwards and forwards so that you'll understand what's happening when you're making too much of it or too little of it. I hope you have a fantastic day. I'm so proud of y'all for continuing with your work. It's really important, I think, for mental health to accomplish things every day and to have a routine. So keep it up. Keep making sure you're taking care of you and your happiness and your sanity. And I'm always here for you if you need me. Bye, guys.